All right, so we have our last lesson, our third form of a quadratic. So we've already talked about standard form and how to graph a quadratic in standard form. So it's like this quadratic up top here, and it's ax squared plus bx plus c. Basically, it's all multiplied out, and it's in order from largest exponent to smallest. Earlier this year, we learned how to factor quadratics using bottoms up. So if we wanted to factor this quadratic, we would do a times c, and in this case, a is 1. So a times c is negative 10. The factors of negative 10, that means what multiplies to be negative 10. So we know one has to be positive, one has to be negative, that add up to the b value, which in this case is negative 3. In this case would be negative 5 plus 2. So in our factors, we go x minus 5 and x plus 2. Now, typically with bottoms up, we would divide by a, but in this case, a is just 1, so that doesn't really affect anything, so that is my factored form. So today, we're going to learn about how to graph a quadratic that's in factored form and what information that can give us. Now, there is technically an a value in front. In this case, it's a 1. So we kind of have this equation here, y equals 1 times x minus 5 times x plus 2. This is a factored quadratic. And then if any point you wanted to turn it back into standard form, you could just FOIL this out, right? So x times x, x times 2, negative 5 times x, negative 5 times 2, and FOIL that out and combine like terms. So you can see here at the top, we have kind of this general form of a quadratic with some a value in front, and then the factors, where p and q, these numbers, are the x-intercepts. We've kind of talked about that in class, and why we call an x-intercept a 0 is because if you set that factor equal to 0 and solve, that tells you when the parabola is on the x-axis. That is when y equals 0. So you'll see that here in just a moment. So our very first step is plot our x-intercepts. So here's our first quadratic, x minus 4 times x plus 2. In step 1 over here, it says set each factor equal to 0 and solve. So for example, if I take the factor x minus 4 and I set it equal to 0 and solve for x when it's on the x-axis, add that 4 over, and we get the x-intercept of 4. So right here on the x-axis is an x-intercept. And then if we take our other factor and we set that equal to 0, so x plus 2 equals 0, and we would subtract over the 2, we get x equals negative 2. So over here, negative 2 is my other x-intercept. Okay, step 2, it says draw the axis of symmetry. We know that that's the line that goes through the vertex. So we kind of have these x-intercepts, but we don't know where is the middle. Where is the vertex going to be at? It's actually pretty easy. The middle, another thing we call, is the average. And you've heard that before in math. The middle is the average. Now, in this case, you can kind of eyeball it. You could see that right smack dab in the middle of these x-intercepts would be 1. It would be the x value of 1. But if it's not as obvious, what you do is you just add up the x values, which the two x-intercepts are p and q, and you divide it by 2. That's the average. You've known that forever. So if I add them up, so if I take 4 plus the other x-intercept was negative 2, and divide that by 2, that's the middle. So 4 plus negative 2 is negative 2, it's 2 divided by 2, which we know is 1. And that's why our AOS is x equals 1. Okay? The way that we find the vertex is exactly like standard form. The way we find the vertex is we plug in the AOS into the original equation and get an output. So it's kind of like an input-output table. So we know that the middle is 1. We just found that out. The AOS is 1. So if we want to find out what its output is, you have to plug it into the original equation. So instead of x minus 4, I'm going to put 1 minus 4. So we have y equals 1 minus 4 times, and then once again, I'm going to plug in 1 up here for this x, so 1 plus 2. And then you just simplify your factors. So 1 minus 4 would be negative 3. 1 plus 2 is 3. And negative 3 times 3 means y equals negative 9. So our output is negative 9. So that's the vertex. That means we go over 1, down 9. That is the middle of your parabola. Okay. Something else we can always graph is the a value. So the a value of a quadratic, which I showed you a second ago, is that number in front. It's the same as all the other forms. It's also the same as absolute value. In this case, it's a 1. So what we do from the vertex, we go over 1, up 1. And then same thing on the other side, reflect that to the other side, over 1, up 1. So this is not stretched or compressed. It's normal. It has an a value of 1. We know if the a value is greater than 1, it's a stretch. And if it's a fraction or decimal less than 1 in between 0, then it's compressed. So this one was neither. And by doing that, we actually just found the y-intercept. We found that it actually crosses the y-intercept at negative 8. But another way you can always find the y-intercept is plug in x equals 0. So in my original problem, if I plug in x equals 0, because I know if I'm on the y-axis, x equals 0, we'd get negative 4 times 2, which we can see is negative 8. We actually already found that by means of graphing the a value, but that doesn't always happen. So for example, if the vertex was over here and the a value is 1, you would still need to find the y-intercept. So we found the y-intercept. If you ever wanted to find more points, you could always just make a t-table, a little t-chart, input, output, x, y, plug in whatever you want. Plug in 3, plug in 4, plug in 5. Plug those into the original equation and get your outputs for each of those. And that's just more additional points. I want you to always have 5, at least 5. So we're already good to go. We have our 5 points over here. So you connect your points. This parabola you can see opens up, and we already knew that because it has a positive a value. But that is your final answer with 5 points. All right, here's example 2. We actually have 4 examples, as you can see on your notes. We have 2, 3, and 4. Okay. They're all following the exact same steps. So if you go back to the first slide here, we graph them all using these 6 steps. So what I would like for you to do is pause the video from here, and on your notes, go ahead and attempt these 7 steps for examples 2, 3, and 4, and then play the video to see if you got it, to see if you got your answers right. So please pause the video, do the examples, and then play the video, see if you got them right. All right, you can see the answers I have here. I plugged in I set the factors equal to 0 up top, and I got the x-intercepts of negative 1 and 3. And then for the AOS, the middle of that was 1. So I put that dotted blue line down. That's kind of like the mirror. That's where the parabola gets split in half at 1. Then the way that we find the vertex is we take 1 and we plug it into the original equation up here for x. You can see I did that there. I simplified, got 2 times negative 2 times 2 is negative 8. So there's your vertex is 1, negative 8. It's down here. The a value is 2. So up front, we have an a value of 2. So you can see I went over 1, up 2, over 1, up 2 from each side. And then lastly, the y-intercept here, we already knew the y-intercept because it was the a value got us that again. But if you plug in 0 for all of the x's, so you can see I plugged into the original equation 0, I get a y-intercept of negative 6, which we can already see right there. Okay, so there's our 5 points. That's enough information to go ahead and draw your parabola. So connect all of these. So you can see it's a little bit skinnier. It was stretched by an a value of 2. So it's a little bit skinnier than our last one that was just a normal a value of 1. And then the last step we don't need to do here because we already have our 5 points. So there's the answer to number 2. Make sure you have already done number 3 before you check the answers here. So give it a try first, and then I'll play the answers here in just a moment. All right, here you can see my answer to number 3. So I got my x-intercepts of negative 6 and positive 2. The middle of that would be the AOS of -2. So you can see I put that blue dotted line down the x value of -2. If you plug in the AOS, which was -2, into the original function for x, we get an output of -4. So remember, the AOS and its output create the vertex. So we have a vertex down here of -2, -4. The A value was 1/4. Now this is a little bit different than a straight line. Typically we would think slope is up 1 over 4. But you can see here, if I start at my vertex and go up 1 over 4, that's way, and up 1 over 4 on the other way, that's way outside. Obviously our parabola doesn't look like this. A parabola should be a smooth U curve, it shouldn't be squared off like that. So it's a little bit different. You always go over 1, and then you go up the A value. So you can see here, from the green vertex, I went over 1, up just 1/4 of a box is what that means. So that's how you can graph the A value if it's a fraction. Always over 1, up the A value. And then lastly, I could find the y-intercept here because the A value was not the y-axis. So when I plugged in 0 into the original equation for x, I got a y-intercept of -3. And remember, once you find one point, you can always reflect that over to the other side just to get another point. It's like a mirror. The AOS is like a mirror. Okay, so we have 7 points here. That's great. That just gives us more definition to our picture. So if we connect all these points here, we can see it was a little bit compressed. It's a little bit wider or flatter than the previous two. All right. If you haven't yet, go ahead and do number 4 and then press play to see if you got it right. If you're struggling getting started for the factors, another way to think of x is x plus 0. It's kind of like x was a GCF, like if you factored out the GCF, but you can still consider that to be a factor with x plus 0. The A value is -3. So see if that helps you find your x-intercepts. And here's the answer to the last question. The x-intercepts were 0 and 4. So I got 0 and 4. Obviously, the middle of that gives us an AOS of 2, or the average of that gives us 2. So I put my blue dotted line down the x value of 2. If you take 2 and you plug it into the original equation for x, so input, output, input the AOS, we get an output of 12. So the vertex is 2 and then 12, which is obviously a little bit up off the graph. Just go, up just 2 from there. The A value is -3, which means over 1, down 3. So over 1, down 3. And we actually, number 5, already know our y-intercept because it was 0. So that's enough information. Go ahead and connect your 5 points. So we connect our 5 points here.
Stephen Lamb to the nurse's office. Stephen Lamb to the nurse's office. Thank you.
And there's your answer.